If you're looking to build advanced generative AI applications, well, you are in exactly the right place. Welcome to this explainer. Today, we're breaking down a foundational concept that takes large language models from being just simple chatbots to incredibly powerful, multi-step problem solvers. We're talking about prompt chaining, and specifically, we'll be doing it using the LangChain framework.
To kick things off, I want you to think about this question. How do you actually make an AI solve complex, multi-step problems, right? We all know that a single LLM prompt is great for a quick question. But when you tackle real-world tasks, like reading thousands of user reviews, extracting the core themes, analyzing the sentiment, and then drafting a cohesive report, a single prompt usually just breaks down. The AI gets confused, it loses context, or it just hallucinates entirely. We absolutely need a way to overcome the limitations of a single massive prompt.
So here's our roadmap for today. We're going to cover the power of chaining, the LangChain framework, the types of chains available to us, a real-world customer feedback use case, the step-by-step implementation, and finally, chaining strategy.
All right, section 1, the power of prompt chaining. Let's get our foundational mental models set up before we look at any code.
Prompt chaining is, honestly, exactly what it sounds like. It involves linking multiple prompts together in a logical sequence, where the output of one prompt serves directly as the input for the next one. Think of it as a highly modular approach to solving complex problems. Instead of asking the AI to do 5 things all at once, you break the task down. You ask it to do step 1, you take that result, and you use it to feed step 2. This is an incredibly powerful technique for things like multi-step text processing, deep summarization, and complex question answering.
Moving right along to section 2, meet the LangChain framework. This is where we abstract all that complexity.
On one hand, you have standard LLM prompting, which is highly manual and prone to breaking. On the other hand, you have the LangChain modular framework. LangChain is this incredibly versatile tool designed to completely simplify the creation of these workflows. It basically manages your LLMs, whether you're using IBM Granite models, OpenAI, Hugging Face, you name it, and it connects your custom prompts into reusable chains. It's essentially a dynamic, structured assembly line for your data. This means you, as the developer, get to focus on actually solving the problem rather than orchestrating the messy back-and-forth API interactions, which, let's face it, can sometimes feel like untangling a massive ball of headphone wires.
Section 3, types of prompt chains. Let's look at the structural methodologies you can actually use.
Just take a look at the sheer variety of workflows you can build here. You've got sequential chaining, which is your straightforward linear progression, simple enough. But then look at branching chaining. This is where a single output splits into parallel workflows. Then there's iterative chaining, where you repeatedly run a prompt until a specific quality condition is met, which is amazing if you need to continually refine an output. You can even use conditional chaining to dynamically make decisions mid-workflow, or recursive chaining to divide massive documents up into smaller chunks and recombine them. The flexibility you have here is just massive.
Okay, section 4, use case, customer feedback. Let's ground all this theory in a practical, real-world application. Imagine for a second we need to process a mountain of natural language customer feedback. Using our factory assembly line analogy, here is a 3-step workflow we could build. Station 1 uses sequential chaining to extract significant keywords from the raw user text. Then, Station 2 takes those exact keywords and uses branching chaining to generate a sentiment summary. Finally, Station 3 uses iterative chaining to refine that summary, ensuring it's completely polished and precise. So raw materials go in, and highly refined, structured insights come out the other side.
Let's move to section 5, step-by-step implementation. Time to actually build this out using Python.
We're going to breeze through these initial 5 setup steps so we don't get bogged down in boilerplate code. First, you set up a Jupyter Notebook environment, say in watsonx.ai. Next, you generate your API key. Install the necessary packages like LangChain and watsonx LLM. Then, you import those essential libraries into your script and safely set your credentials using the getPass module to protect your keys. Pretty standard, best practice setup, right? Now, step 6 is where it gets interesting. We instantiate our specific AI engine. Here, we're initiating the IBM Watson LLM, specifically the IBM/Granite 3-8B-Instruct model. This particular model is explicitly designed for instruction-based tasks, which is perfect for us. Notice that we also set our guardrails here, like capping the max_new_tokens parameter to 150. This is super important because it keeps our output concise and controls our overall computational costs.
Step 7 is absolutely critical. This is where we define our individual prompt templates. Think of these templates as the specific structured instructions for each station on our assembly line. We create a keyword_prompt that tells the model exactly how to pull keywords from a text placeholder. Then we have a sentiment prompt that takes those extracted keywords to generate a summary. And finally, a refine prompt to polish the final output. Creating these reusable templates ensures absolute consistency in our prompt engineering across the board.
Moving to step 8, we wrap our prompts and our language models together by creating individual LLM chains. This is specifically where we assign unique output keys to each step. So the keyword chain outputs a variable clearly labeled keywords. The sentiment chain outputs sentiment_summary. And the refinement chain outputs refine summary. This labeling is absolutely vital because it ensures our data is perfectly organized for the next stage of the pipeline.
Step 9 is where everything connects. We combine these 3 individual chains logically into a single sequential chain. Let me emphasize the why here, because this is key. We do this because the sequential chain automatically pipes our extracted keywords directly into the sentiment prompt and then pipes that summary straight into the refinement prompt, all without any manual intervention from the developer. It magically links these distinct tasks into one fluid automated pipeline.
Finally, step 10, we execute the workflow. We define a multi-line string of raw user feedback, say a user is complaining about app crashes but praising the new features, and we just feed it directly into the workflow.run method. We hit execute, and the data just flows through all 3 chains automatically.
And here is what the AI outputs. The user's sentiment is predominantly negative due to recurring app crashes. The development team should focus on resolving app crashes. Boom. This perfectly proves that the system works. It took messy, multi-line raw feedback and distilled it into a highly actionable critical insight. And it did it without us having to write complex, fragile, single-prompt instructions. All right. Section 6. Choosing your chaining strategy. Let's wrap up by exploring how to apply this to your own projects.
So before you write a single line of code, you really need to evaluate these 4 criteria to ensure your application architecture is actually efficient. First, task complexity. If you have multiple steps, use runnable workflows or few-shot examples to structure them. Second, dependency. If step 2 absolutely requires the exact output of step 1, then sequential chaining is your best friend. Third, adaptability. If you need a dynamic workflow that adjusts in real time, like an AI agent fetching live web data, you'll want iterative or dynamic chaining. And fourth, data modality. If you're mixing text, images, or vector embeddings, make sure your chosen workflow can actually handle multimodal data.
We've seen how LangChain and prompt chaining can take a totally unpredictable LLM and turn it into a structured, highly reliable assembly line for complex tasks. So I'm going to leave you with this final thought to spark your curiosity. Armed with these new tools and frameworks, what complex multi-step workflow are you going to automate next?